Hi guys, good evening everyone. Welcome to the session and welcome back to the GATE and ESE 2024 fundamental session. And in this fundamentals, as you know, we have been discussing signal and system for quite some days, starting with the very fundamental concepts of signals, be it time folding, time shifting, time scaling, then all important signals like unit impulse, unit step, unit ramp signals, and etc. Several concepts we have been talking about. And guys, now the time, just a moment. Oh, just 1 second, guys. Hey dear, what happened? Yeah, let me plug this in. Okay, and now is the time to move on towards the next important concept, and that is about periodic signals, periodic and aperiodic signals. Okay. But you will notice that the rules for continuous time as well as discrete time, slightly differ. The rules for continuous time slightly different from that of the discrete time, and that is why I am taking the separate session on that so that we have a complete clarity. Today, we will first talk about the continuous time periodic and aperiodic signals. Next, tomorrow, we will talk about the discrete time periodic and aperiodic signal, and then we shall clearly understand the difference between both of them. And let us get moving ahead. Let us get started. Okay, this is a brief intro about me. This is Rakesh, secured All India rank 9th in the GATE examination and completed my master's from Indian Institute of Science, Bangalore. And yes, guys, as we have been updating you, the coming Sunday, that is 2nd of April. Yes, guys. Okay. From this Sunday, the 2nd of April, we are starting a fresh brand new series for you, okay, to help you learn with real practical experiments, and we call this as Learn with Fun. Okay, and if you want to understand what this Learn with Fun is, I'll give you the trailer of the first session that is going to come on 2nd April. The first session is, guys, skin effect. And as you're able to see, okay, me and Ashu sir have performed some experiment, okay, to explain you very simply, very clearly what is skin effect. Okay, that experiment we performed, and after that experiment we have recorded the theory, the formulations about the skin effect. Okay, so this is what Learn with Fun series is. This is first Sunday. This is going to be live on 2nd April. This is the first video. Okay, then next Sunday another such video. So make your learning more interesting. Your skin effect is a concept. Questions keep on coming from here, but to make it more effective, let's have a demonstration of that. Okay, guys. Now, guys, let's get started. Okay, let's get started. Deepa, it totally depends. You're asking about two totally different. If you talk about computer science, placements are good. VLSI placements are good. Okay, so it depends on where do you want to see yourself, what is your interest area, whether it is computers and data or whether it is VLSI. Okay, so you have to, both are good. Okay, in the top IITs, both are good. Take a call first or based on your interest level. Where do you want to see yourself and you are good at what positions. Okay, so guys, so we all know, fundamentally you all must be knowing, okay, that what periodic signals are. Okay, there's a signal whose value repeats after every finite duration of time. After every finite duration of time will be a periodic signal. Now, as you're able to see, for this particular signal, the value, what is the waveform at the origin? It's like a rectified wave. Rectified sinusoidal wave, okay, starting from 0, okay, then at t equal to 1, again the same nature repeats, t equal to 2, again the same nature repeats. So the wave nature repeats, the signal nature repeats after every certain distance, after every certain time, and that time is basically defined as the time period. So every periodic signal will have a time period, okay, and this is known as the one cycle. Every periodic signal is known as what is the time period. Acha. What is the time period here? It is equal to 1. And if you know the time period, you can clearly say that, okay, the value of the signal after the time period. Okay, so there is some value of the signal. Okay, there is some value of the signal that is at some time t. But the value of the same signal at the time t plus capital T will be the same. That is why we call it as a periodic or repeated signal whose value repeats after every finite duration capital T. Acha, not only this. Okay, this is the fundamental thing. Okay, where t will be known as the fundamental time period. We'll have all definitions also officially coming up. But not only this, if I say x of t if I say here x of t is same as x of t minus 1 or plus 1. Okay, either if I go right shifted, either if I see left shifted, both are equal. But not only this, it repeats. If it repeats after 1, it repeats after another 1 unit of time. Matlab, it repeats after total 2 unit of time also. Okay. This nature at t equal to 0 and t equal to 2 is same. It will repeat at t equal to 3, it will repeat at t equal to 4. So it will repeat after every 1 unit of time. It will repeat after every 1 unit of time. Okay, so it can be written as even xt plus minus 2 or x of t plus minus 3, etc, etc, etc. In general, I can write down that x of t can be equal to x of t plus nt, where n can be any integer, positive or negative, right? Where n can be any integer. Okay, right? This is also an example. This is a regular sinusoidal wave. Achha, if we talk about, sorry, it has to be on the left hand side also, because if there is a signal which I call it as periodic, it has to be periodic from minus infinity to the plus infinity. Right, pure periodic signals are periodic from minus infinity to plus infinity, and this is what is the very common example that you know for a sinusoidal voltage waveform, right? This waveform, okay, let's say the amplitude is equal to A. This waveform is nothing but known as the A sine omega t. Okay, A sine omega t. And whether you take this particular portion, right, or you take any particular, see, you can measure it from origin, you can measure peak to peak, you can measure from crest to crest, anywhere, you can measure from any portion. Okay, the point is, there is something which is known as the time period, and the information contained in one time period is known as the one cycle. Acha, what is the time period for sinusoidal waveform? Everybody knows the formula. Okay, but if I fundamentally have a look into the mathematical calculation, we know that xt is equal to A sine omega t. Xt is A sine omega t. But we also know that what is the angle, if I talk strictly in terms of angle trigonometry mein, after how much angles the value of sine theta repeats. So sine theta is periodic with the period of 2 pi. Sine theta plus 2 pi is equal to sine theta. Sine theta plus 2 pi is equal to sine theta. Correct? Right. So looking into that angle, I can say that sine of omega t plus 2 pi should be equal to sine omega t. Should be equal to sine omega t. That is what we can say, na? Okay. So this is omega t plus total 2 pi, theta plus 2 pi, but this can be rearranged if I take omega common. Let us see how much is the addition in time specially. If I take omega common, it can be written as t plus 2 pi by omega, and this is equal to sine omega t, right? So that clearly means that if I take x of t plus 2 pi, by t is replaced as t plus 2 pi by omega, sorry. Okay, here if I take x of t plus 2 pi by omega, it is clearly coming equal to the xt. That means this is periodic. We know it is periodic. And how the period is 2 pi by omega? This is the way you can say. So if this is periodic, what is the time period? Xt is equal to x of t plus capital T. So what is that capital T? That is 2 pi by omega. Okay. So the time period for any sinusoidal waveform is given by 2 pi by omega. So guys, be it A sine omega t, right, or even be it A cos omega t, both of them are always periodic. Now that is the difference you will learn tomorrow. If I talk about these signals in discrete time domain, they are not always periodic. They are not always periodic in discrete domain, but in continuous time domain, they are always periodic. And if they are periodic, I can specify the time period, and that is given by 2 pi by omega. Yeah, Jagdish, we can plan classes. Signal function, I have slightly given you the hint in the step signal class only, but we can plan separate videos for that. No worries. Okay. So that is what, as I told you, t is the period, then 2t, 3t will also be the period, but the smallest value of time, okay, the smallest possible value of the period, that is important for us, and that is what we call it as fundamental period. As already I told you, if the value repeats at 1, it repeats at 2, it repeats at 3, everywhere. But what is the smallest duration of time after which repetition occurs? That is known as the fundamental period. Simply we call it as period. So when I say time period, by default, it is fundamental period. Okay. The inverse of that is the fundamental frequency in hertz. which we call it as 1 by t. Okay, this is the frequency which we measure in hertz. The omega, which is 2 pi by t, that is the radian per second. Okay, of course, also the same point I mentioned, for a signal to be periodic, to be a pure periodic signal, it must have the existence from minus infinity to plus infinity. Already I mentioned about this point. This is yet another, I'm just showing you some waveform examples before we go to the question. This is yet another periodic signal. So dear, what should be the period of this periodic signal? So now, how do you measure the period? You can measure, see what is being repeated here. Okay, rectangular blocks are being repeated here. So if you, so I have seen very few cases, but yet I have seen some students, not able to analyze what exactly the time period is. So that is why pura basic se chalte hain, right? So what is the time period? So if you are measuring the time period of the rectangular block, repeated rectangular block, either measure center to center. So how much is the gap? 2 units. If not, you can take it like this also. By the end point to the end point, yeah, more commonly starting of the first block to the starting of the second block. So how much is this? Minus 0.5, say 1.5, that is still 2. So anyways, you can measure the time period, the time gap between any two similar points. Okay, where you see the repetition. Okay, this is a triangular sort of waveform. What is the time period for this? Then we will do many other calculations. Well, let's take lete. Acha, once you are clear with the topic of periodic aperiodic signal, very useful. This is going to be used in Fourier series analysis. Fourier series analysis. Again, now if I measure center to center, so 0 and 3, this is total time period 3. Or if you want, you can measure with this discontinuity, where this first rectangular block is starting and this next one. So minus 1 se leke 2 hua na. So what is the time gap between minus 1 se 2? What is the time gap between minus 1 se 2? That is equal to 3 units. So anyways, this is a signal having the time period of 3 units. This is what is commonly known as a sawtooth waveform. Okay. Important questions are expected here with respect to power calculations also. In the upcoming classes, we will learn about the power of periodic signals. How do you calculate? This is a sawtooth waveform. Okay. This is the time period. Okay. That is center to center we measure here, so that is t equal to 2. You can measure from starting point to starting point, etc. These are some fundamental examples. Now, starting with very simple question, whose answer everybody can give, I think. Everybody can give. What is the fundamental period and fundamental frequency of this signal? So, sir, what is the fundamental period? That is simply, see, this is of the form sin omega t, na? Okay, so what is the time period? What is the frequency? Okay. So frequency omega is 2 pi by 3. Okay. When I say frequency omega, that is in radian per second. So what is the time period? Time period we know is 2 pi by omega. So when you take 2 pi by omega, that is going to come up as 3 seconds. So time period of the waveform is 3 seconds. Okay, very fundamental. Everybody can give the answer looking into it. Now tell me the fundamental period of j e power j10t. Now not only this, in general, if I take a signal which is of the form a e raised to the power j omega naught t, simply omega t likhte, a e power j omega t plus any additional phase also. Why? Because when you talk about j, the complex number j, it can be written as e power j pi by 2 in the Euler form. Let us also write this in the exponential Euler form only. Right, e power j pi by 2, reverse kijiye na. What is e power j theta? Cos theta plus j sin theta, right? Cos theta plus j sin theta. Now, here if I take e power j theta, this will also be broken as cos theta plus j sin theta, and that is why this will also be periodic, pretty much having the same result. But let us see this separately. Okay, so if j is e power j pi by 2, what is going to be the xt? Xt becomes e power j pi by 2 into e power j 10t. That means your signal is e raised to the power j ko common liya, so 10t plus some phase, plus some initial phase, that is pi by 2. Let us say that is 5. So if in general, this is the signal given to you. Okay. Whether this will also have the same period. Okay, one simple way of rectifying it. Okay, this is the next important class, the exponential, the complex exponential, whether they are periodic or not. So guys, once again, I know that e power j theta is broken as cos theta plus j sin theta eventually, and cos theta and sin theta, they will have the period of 2 pi. So what I'm just going to try, what is x of t plus 2 pi. Kar lete hai na, try. So what is this? E power j omega t is replaced by t plus 2 pi. t is replaced by t plus 2 pi, right? So this is equal to a e raised to the power j omega t plus, sorry, 2 pi by omega, sorry yaar, in hurry bari I wrote 2 pi. Why it is 2 pi? 2 pi by omega. For sine theta we write theta plus 2 pi, but this is omega t na. Okay, so total omega t should be added with 2 pi, and for that t should be written as 2 pi by omega. Addition of time should be 2 pi by omega. So ये कितना हो गया? Now this becomes 2 pi, and then we have the phi additionally. Now I can split this a e power j omega t plus phi as it is into e power j 2 pi. I split it the exponential terms, e power j 2 pi. Now dear, what is the value of e power j 2 pi? You can write down what is the value of e power j 2 pi. That is given by Euler's identity, na, cos theta plus j sin theta. Cos 2 pi plus j sin 2 pi, cos 2 pi 1, sin 2 pi, sin 360 0, cos 360 1. So this is equal to 1. And dear, if this is equal to 1, so what is left? What is left? A e power j omega t plus phi, that is the original signal. That means x of t plus 2 pi by omega is again equal to xt. That means even this complex exponential signal has the time period which is 2 pi by omega. You can also understand its logic by the relation with the sinusoid signal cos theta plus j sin theta. So that means, guys, what is the fundamental period of this signal? The fundamental period is given by 2 pi by omega, and that is nothing but 2 pi by 10, because omega equal to the 10, and 2 pi by 10 can be written as eventually pi by 5. So that is the answer for the question. It is actually pi by 5. That is the time period, right? Next. Is the signal cos 5t ut periodic? Cos 5t ut periodic? Straight away, answer is no. Why? Straight away, answer is no. Because I told you, for a signal to be periodic, for a signal to be pure periodic, it must have the existence. It must have the existence from minus infinity to the plus infinity. But ये कैसा चलेगा? Cos t ut. Because of the ut, the signal becomes right-sided, because unit steps only start. The unit step only starts after the t greater than 0. So this is what is going to be the waveform. The cosine waveform, no doubt, but only on the right-hand side. But the signal here is 0. The signal doesn't exist on the left-hand side. Signal doesn't exist on the left-hand side. Clear hai? So that is why it is not a periodic signal. Okay, its value should repeat for all values of time from minus infinity to infinity. Cos omega t is periodic. Cos omega t into ut, not periodic. Not periodic. Chalo. Another interesting question. Even part of cos 2 pi t ut. Acha, for a quick revision, dear, how do you calculate even part of any signal? How do you calculate even part of any signal, xct? That is given by the formula x of t plus x of minus t divided by 2. Because this part is always going to be an even function, an even symmetric function. How do you calculate odd part of any given signal? Odd part of any given signal. Odd part of any given signal, that is x naught t, is defined as x of t minus x of minus t is divided by 2. X of t minus x of minus t divided by 2. That is the x naught t. Done. ठीक है. That is known as the x naught t. So guys, is cos 2 pi t ut? See, cos 2 pi t ut is not periodic. Already I told you, even part of this function. Okay, so what is that even part? Let me start calculating, dear. What is that even part? As I told you, that should be written as xt plus x of minus t whole divided by 2, and that should be equal to, what is xt? Cos of 2 pi t multiplied by the ut plus cos of minus 2 pi t multiplied by the u of minus t, right? Whole divided by 2. But dear, you all know that cos minus theta is cos theta. Cos theta itself is an even function. So cos minus theta is cos theta. Cos minus theta, this part is directly equal to cos theta, that is cos 2 pi t. And that is why I can take out cos 2 pi t common. cos 2 pi t common, then I am left with ut plus u minus t, and of course there is whole divided by 2. What is ut plus u minus t? Ut plus u minus t is equal to the 1. As we have learned in the unit step class, ut plus u minus t equal to 1. And eventually I can say that the even part of the signal is nothing but half cos of 2 pi t. Half cos of 2 pi t. Ut plus u minus t is equal to 1. And that is half cos 2 pi t. And the signal half cos 2 pi t, we all know, is periodic. This is of the form a cos omega t, and the fundamental frequency is 2 pi. The time period is given by 2 pi by omega, and the time period is equal to 1. And dear, before I comment anything else, if you have understood this question, you should be in a position to answer me the next question. Even part of sine 2 pi t ut. Please try it out for a minute and just allow me a minute. Okay, yeah. So let me just check if you are done with this. Even part of sine 2 pi t ut. Even part of sine 2 pi t ut. So let us again start xet as xt plus x minus t divided by 2. Xt plus x minus t divided by 2. Okay, now xt, that is sine 2 pi t ut. Sine 2 pi t ut plus x minus t, that is sine minus 2 pi t u minus t whole divided by 2. Okay, cos theta was even function, but sine theta is odd function. Sine minus theta should be written as minus sine theta. Sine minus theta should be written as the minus sine theta, and that is why this will become sine 2. Okay, sine 2 pi t will become common anyways, but inside the bracket I have ut minus, that's the minus sine theta, minus will come, and minus u minus t whole divided by 2. Now dear, ut plus u minus t was equal to 1, but here it is ut minus u minus t, and that is why your signal is becoming sin 2 pi t into ut minus u minus t, that is given by the signum function, signum t whole divided by 2. ut minus u minus t क्या होता है? signum t, right? Or okay, anyway, signum is aperiodic. Because of the signum part, it becomes aperiodic. Or if you want, you can understand with the waveform as well. You can understand with the waveform. Waveform ये बोलता है that the signal on the right is sin 2 pi t. The signal on the left, u minus t exists, it's a mirror image of unit step signal that exists on the left hand side. Okay, but what is multiplied with u minus t? That is minus sin theta. So actually the left hand side, this is the sin theta. But I have minus sin theta. I have minus sin theta. Okay. Now this makes it aperiodic. This makes it aperiodic. This is the waveform. Because, right, if you see, if this is one cycle, right, so here negative going waveform should come. So यहाँ पे भी negative होना चाहिए था, but it suddenly becomes positive. Negative to positive, then it should be negative to positive. Okay, so here it is negative to positive, then change the nature positive to negative. That is why this is clearly the waveform which is aperiodic. Graphically भी समझ लीजिए. So either you see by the function because of signum t, or either you look into the waveform, it is anyways aperiodic. Okay, and because it is aperiodic, we can't calculate any period or any frequency of the signal, right? Clear? Any period or any frequency we can't calculate here. Okay? So you have to take it into such case. And if you have understood both the cases, I'll give you a homework now. The homework is, okay, calculate the period, if periodic, for odd part of cos 2 pi t ut. अभी हमने दोनों के even part पे किया ना? Okay. Solve for odd part of cos 2 pi t ut, odd part of sin 2 pi t ut, and see what are the results you get. These are the two homeworks. These are the two homeworks. Now, what happens when periodic signals are added? What happens when periodic signals are added? What happens when periodic signals are added? Tell me. What happens when periodic signals are added? चलो देख लेते. So suppose there is a signal x1t which is periodic. Right, and let's say its period is equal to t1. Okay, there is another signal x2t which is also periodic. There are two different periodic signals, and let's say its period is equal to t2. Let's say its period is equal to t2. Acha, what is the basic definition of periodic signal? x1t is periodic, means x1t can be written as x1t plus t1 plus the time period, or it can also be written as x1 t plus mt1, t plus mt1. At the same time, x2t is periodic with period t2. So what is the x2t? x2t can be written as x2t plus t2, or in general x2t plus nt2, where m and n can be any integers, as I already explained you in the beginning of the video. Okay, now I want to talk about addition of periodic signals. Okay, if I consider a signal xt which is equal to x1t plus x2t, what about the period of this signal? Which is x1t plus x2t, what about the period of this signal? Right, what about the period, or whether it is periodic or not? First of all, periodic होगा तभी तो period की बात करेंगे. So whether this is periodic or not, so a simple way of understanding. Let us say this is periodic. Okay. Let us say this is periodic. With some period that is t. मान लेते हैं. So if this is periodic, x of t should be equal to x of t plus t. Correct? X of t should be equal to x of t plus t. Now dear, write down xt. xt is x1t plus x2t. But as per the previous discussion, because x1 and x2 are both periodic, okay, let us use their periodicity definition, and x1t can be written as x1t plus mt1, and similarly next वाला लिख देंगे तो x22 is x2t plus nt2. right? On the other hand, what is x of t plus t? X of t plus t यहीं से change करो केवल. If xt is x1t plus x2t, what is x of t plus t? That is x1t plus t plus x2t plus t, right? Now dear, compare both. Do one thing actually, इसको थोड़ा सा right shift करके लिखते. So let me write down the second equation like this. So what is x of t plus t? That is equal to, right side also, x1 t plus capital T, then x2 t plus capital T. But I know these two should be equal. xt should be x of t plus t if it is periodic. अगर वो periodic है तो, right? And for these two should be equal. What is the capital T? What is the assumed time period? That should be mt1, and that should also be equal to nt2. That is the condition. It should be equal to, the time period should be equal to mt1, or that should be equal to nt2. So यहां से पहले एक condition बनेगी. If time period is equal to both, so eventually these two are also equal. mt1 is equal to nt2, and that means t1 divided by t2 should be n by m. Sir, what is n? What is m? Both are integers. Both can be any integers. So what is t1 by t2? It is ratio of integers, and ratio of integers is a rational number. So here comes the condition in front of you. Okay. The addition of two signals will be periodic if t1 by t2 is a rational number, if the ratio of time periods, if the ratio of their time periods is a rational number, if the ratio of their time period is equal to the rational number. Achha, then what is the final time period? Final time period is mt1 or nt2, any of this. Matlab what I can do is what I told you, mt1. अच्छा नहीं, यहाँ पे शायद name को change कर दिया है, right? So t1 by t2 should be n by m. Let us follow the same trend. I have taken n by m, na? I have taken n by m. So same thing we shall follow here. Just a moment. इसको erase कर देते हैं. Sorry. Just a moment, है ना? Yeah. So have a look into this. It should be equal to n by m, ratio of two integers. That is a rational number. And if it is a ratio of n by m, what is the final time period? You can just do the cross multiplication. It is nt2 or mt1. That is cross multiply. आप केवल cross multiply कर दीजिए mt1, or that is equal to nt2. Okay, that is obtained by cross multiply. I'll write down here. And also there is one more way of calculating the period. You can either use the cross multiplication method, or you can directly find the LCM of T1, T2. You can find the LCM of T1 and T2, because MT1 means a multiple of T1 and T2 is a multiple of T2. So the time period is a multiple of T1 as well as a multiple of T2. That means it is the common multiple. Why I want the lowest common multiple? Because the time period is the smallest value of time for which repetition occurs. That is why it is the lowest common multiple. आ गई बात समझ में? The time period is a multiple of T1 as well as a multiple of T2. That is why it is the common multiple. And fundamental time period means the lowest common multiple. So that is also another method. Well, this is the complete explanation of the addition of periodic signals. अब मुझे quickly इसका आंसर बताइए. Yes, dear. Whether the signal is periodic or not, and if it is periodic, tell me the time period. So now there are two signals given to you. Okay, there is a signal having what time period? The 2 pi by omega. Okay, which is 1 by 2. What about this? T2. 2 pi by omega. That is 2 pi by 10 or pi by 5. Very clearly. One of them involves pi, another one doesn't involve pi. So when you divide, there will be a factor of pi, and pi is an irrational number. So the answer is going to be aperiodic. पहले मैंने answer mark कर दिया. Sometimes you can just look into, say, one of them contains the time period in terms of pi, another one doesn't contain pi. So when you take the ratio, eventually you have the ratio test, na? T1 by T2. T1 is 1 by 2. T2 is pi by 5. सिंप्लीफाई किया तो 5/2 pi, okay, which is irrational. I want ratio of integers. This is irrational, and that is why the signal is not periodic. Clear? Is pi rational? So some of the students think, sir, pi hota to hai 22/7. It is a ratio of two integers. So why not pi is a rational number? Dear, 22/7 is the closest approximation to the value of pi. It is not perfectly equal to. Pi is approximately 22/7, but it cannot be perfectly written as 22/7. Please remember, okay? Please remember this. Next one. Now there are two signals given and you have to comment whether both are periodic, both aperiodic, one of them periodic, or whatever it is. Okay, let us comment on this question now. Let us comment. And then we can talk about addition of 3 or more signals as well. 3 or more की बात भी कर सकते हैं. Not a big deal here. Let us complete this part actually first. Okay, so what is the first part? है ना? First part में जो time period T1 है. Okay, what is the time period T1? That is 2 pi upon 8 pi, that is 1/4. What is the time period T2? What is the time period T2? That will be again 2 pi by omega, that is 2 pi by 6 pi, and that is 1/3. So what is T1 divided by T2? Both of them doesn't contain pi, so there will not be any irrational case. ये हो गया 1/4, ये हो गया 1/3, that is given by 3/4. Okay, so it is a rational number. So rational test is qualified. So the first signal is periodic. First signal is periodic. And if it is periodic, if I want to ask the period, वैसे पूछा रही है, but if I want to ask the period, so what is going to be the period? As I told you, na, cross multiply. Cross multiply. So 3T2 or 4T1, any one of. Cross multiply किया. ठीक है. So what is the 3T2? T2 कितना था sir? T2 is 1/3. So 3 of 1/3 is equal to 1. That is the answer. Or 4T1, if you take 4T1 will also be 1. दोनों से आंसर सेम आएगा. Any one of the cross multiplication you can use. The first signal is periodic with the time period 1. With the time period 1. Sir, what about the second signal? Now, second signal where the first signal has the time period which is 2 pi upon 8 pi, which is 1/4. The second signal has the time period which is 2 pi divided by 20 or pi by 10. And one of them is in pi, one of them. See, either both contain pi or both do not contain pi. But if one of them contains pi, the ratio will be not possible to be written. So what is T1 divided by T2? 1/4 is divided by pi by 10, and that is equal to 5/2 pi. That is equal to 5/2 pi. Again irrational. Okay, so what is the correct answer? The correct answer is first is x1t is periodic, x2t is aperiodic because it fails the ratio test. A is the correct answer. Yes, Arumugam. A is the correct answer. Moving to the next question. Please answer this. Match the list 1 with the list 2 and select the answer using the codes given. Okay, F1t, F2t, F3t and a combination of them. And some combination of them. Tell me, dear. Tell me. Think about this and tell me. Yes, dear. Let us match the answer then. If the DC value is added, we'll come to that question also, Anshu. Okay. 0 nahi hoga. What happens when the DC period is added? Right. Chalo, have a look into this, guys. So this is very simple. The first one is very simple. What is the time period for the first one? That is 2 pi upon 2 pi by 3. That is equal to 3. Okay, that is equal to 3. So ye aa gaya P. Right. For the third one, individually, guys, in the continuous time domain, sin omega t is always periodic. Right. So time period is given by 2 pi by 3. Okay, simple. This is simply 2 pi by 3. Okay, so this corresponds to R. Right. P2 and R ka 4. ये क्लियर है? अरे बाबा, हाउ सिंपल इट इज. Okay, P goes with 2, R goes with 4. So correct answer is D. Correct answer is D. Okay, but still we will complete. ये तो match हो गया. Okay, but what about the second one? It is a multiplication. Okay, addition मैंने बोल दिया. चलो fourth वाला देख लेते हैं. What is the F4T? What is the F4T? Okay, F1T minus 2 F3T. What is the F1T? Okay, what is the F1T? Sine 2 pi by 3T minus 2 F3T. Okay, minus 2 and F3T is equal to sine 3T. Sine 3T. Clear, everybody? So now we know that the first time period, this is about addition or subtraction. We know this is the time period 3 and this is the time period 2 pi by 3. One of them does not contain pi, another one contains the pi. So when I am going to take the ratio T1 by T2, that is 3 upon 2 pi by 3, or that is 9 upon 2 pi, irrational, aperiodic. Irrational है तो aperiodic. Okay, irrational है तो aperiodic. That means the S will come here. So S should be 3. S should be 3. Already I have told you answer is D. Sometimes option matching help you a lot, but still I am explaining you the complete detail. And next is Q. Next is the Q. Okay, Q की बात करते हैं. Okay, that is the signal F2T. What is the signal F2T, dear? F2T, sine 2 pi by 5T. This is equal to sine 2 pi by 5T is multiplied by cos 4 pi by 3T. Cos 4 pi by 3T, multiplication of sinusoids. Multiplication of sinusoids. So here you will use one property. Multiplication of sinusoids, you will use a property, and that is sin A cos B. Sin A cos B. And what is sin A cos B? That can be written as sin A plus B plus sin A minus B whole divided by 2. Whole divided by 2. Sin A plus B plus sin A minus B divided by 2. So that means the signal F2T, okay, will be equal to sin of A plus B. So sin of 2 pi by 5 plus 4 pi by 3T. ये हो गया? Right, plus 4 pi by 3 है. Plus sin A minus B. So plus sin 2 pi by 5 minus 4 pi by 3T whole divided by 2. Okay, so F2T is actually now equal to 1 by 2 separate किया. Sin of how much? If I just do this rough calculation, 2 pi भी common लिया तो 1 by 5 and then I will have 2 by 3, and this will be simplified as 15, 3 plus 10, 3 plus 10, 13. Okay, so 2 pi into 13, 26 pi divided by 15T. That is the first one. Okay, 13 2s are correct. And next will be equal to, इसको minus किया, so this also becomes the minus, and that will be minus 7. तो sin minus 14 pi, तो minus को बाहर कर देते हैं सर. Sin minus theta is minus sin theta. 14 pi divided by 13 into T. Okay. Now dear, I have the first time period, that is 26 pi upon 15, and I have the second time period which is equal to 14 pi upon 15. ये typo error है, denominator is 13 only. Just check the calculation once, है ना? Just check the calculation. I think minus 7 into 2 pi, perfect है. So both of them contain pi, so answer will be periodic. Okay, answer will be periodic. When I take T1 by T2, 15 be cancel, pi be cancel. It is 26 by 14, or that is 13 is divided by 7. Express in the simplest form, because you want the fundamental time period lowest value. So don't use cross multiply, don't use 26 by 14. Write down 13 by 7, and then the time period should be equal to 71. Either 71 or 13 any of them. So what is the value of 71? T1 का value बैठा हुआ है वहां पे. What is the T1 value? Here it is. Sorry dear. ठीक है. It is periodic. Sorry. Just in hurry, I have made some calculation mistake. No problem. T1 is equal to that. I actually wrote omega, but you are able to understand what is the flow going on. So that is 2 pi upon 26 pi divided by 15. Okay, upon 26 pi divided by 15. So this should be 15 by 13. T2 is 2 pi is divided by 14 pi upon 15, and that will be equal to 15 is divided by 7. And again, dear, if you take T1 by T2, 15 by 13 and 15 by 17, it will come up 7 as 7 by 13. Ratio of integers, rational numbers. So final time period will be equal to 7 times T2. 7 T2 cross multiply kiya, and that will be 7 into 15 by 7, and the time period should be the 15. Time period should be the 15 year. So this corresponds to Q. Already I matched the option. Already I had matched the option, but still for clarity, we have solved all the 4 parts. For the sake of clarity, we have solved all the 4 parts. So now you have also known, guys, even if it is addition or minus, subtraction, results are same for both. I'll actually mention here. Okay, whether it is x1t plus x2t or minus x2t, the results will be similar for both because of the explanation that I have given you. Even minus will have the same results. Okay, and also in this particular question, you have learned about multiplication of sinusoids. You have to use the trigonometric identity, sin A cos B or sin A sin B, cos A cos B. Some trigonometry identities will be used here. Okay. Chalo. Sir, if 3 signals are there, what is the fundamental frequency of the signal here? A fundamental time period, any of the thing they can ask you. So if there are the 3 signals, then what will happen? Cos 1.2 pi t plus cos 2 pi t plus cos 2.8 pi t. Tell me. So no worries, even if it is 3 cases. Okay, you can do the cross multiply trick 2 times, or you can directly go with the LCM method, right? So what is the time period T1 here? The time period T1 here is 2 pi upon 1.2 pi. Okay, that is 2 upon 1.2, and again that can be 20 by 12, or in the very simple form, if you cancel with 2 or if you cancel with 4 actually, so that becomes 5 by 3. Okay, ye ho gaya T1. Sir, what is the T2? That is 2 pi upon 2 pi, that is simply 1. And what is the third time period? That is 2 pi divided by 2.8 pi. Okay, so that is 20 by 28, or cancel by 4. It is 5 by 7. Okay, none of them involves pi. So everybody will satisfy the ratio test. Okay, everybody will satisfy the ratio test. T1 by T2 kitna hua? 5 by 3 by 1. So that is 5 by 3. Okay, so what is the period for x1t plus x2t? What is the period? Suppose that is equal to t dash, and that will be equal to cross multiply kijiye. So 3t1. What is the t1? 5 by 3. So that is equal to 5. So period for x1t plus x2t combined. Is t dash. Okay. Now x1t plus x2t plus x3t. Right. Okay. So what is the time period for them? First ratio test lenge hum. Right. This has the period given by t dash. This has the period already t3. So what is t dash by t3? T dash abhi humne nikala 5. T3 is 5 by 7. Okay, so it becomes 7, yeah, which can be written as 7 by 1. So final time period should be 1 into t dash, and that is equal to 5 again, or 7 into t3, anything. Okay, so that is equal to 5 eventually. So answer, final time period is 5. Frequency hertz mein pucha hai, to 1 by 5 is 0.2 hertz. It is 0.2 hertz. So the correct answer is option number A. The correct answer is option number A. The correct answer is the option number A. Badhiya? The correct answer is option number A. Okay. So that is the correct answer. Acha. Now, let us see the one more case, dear. What is the fundamental period of cos square? Sin square ya cos square? Sin square ya cos square? So let me tell you one simple thing here. Sin square ya cos square? Eventually, guys, what is cos square theta? Cos square theta can be written as 1 plus cos 2 theta is divided by 2. 1 plus cos 2 theta is divided by 2. लिख सकते हैं trigonometric identity. So that means what will be the xt? So xt is equal to cos square 3t, and that is 1 plus cos 2 theta. So cos of 60 into 2 kiya, so cos of 60 divided by 2, or this can be 1 by 2 plus 1 by 2 cos 60. Now that DC component, if some of you are asking, na, is the DC component going to make the signal aperiodic or going to make the period 0? No, nothing like that. It will still be periodic, having the period whatever is decided by cos 60, because what is the role of this? What is the role of this DC component? Hey, what is the role of this DC component? If you try to understand with the waveform, okay, cos 60, half cos 60. Acha, what is the cos omega t? Okay, what is the cos omega t? Everybody understand? This is the cos omega t. Amplitude half बाद में ले आएंगे. Okay, this is the cos omega t. This is the cos omega t, which exists from 1 and minus 1. Then I will divide by 2 later on. This is cos omega t. Now I want to add 1. Forget the 2 right now. Forget the divide by 2. 1 plus cos omega t. So what is 1 plus cos omega t? Okay, what is 1 plus? Adding 1 to a signal, already I explained in the fundamental classes. Adding 1 to a signal is raising its magnitude. That means raising the height along the y-axis. Okay, you are adding to the amplitude 1 plus the signal. That means all amplitudes will be raised above. The signal will be raised above by 1 unit. So 1 will go to the 2 and minus 1 will come to the 0 level. So if that is the case, it's going to be something like this. It is going to be something like this. Oh, what happened? I don't know why it got erased. It is going to be something like this. This is going to be something of this kind. Clear, everybody? Okay, then divide by 2 magnitude, no problem. The magnitude was equal to, this was 0 and this was 2. 2 divided by 2, this is going to be 1. But eventually it is periodic, na? Eventually it is periodic. Okay. So the DC component will not affect. You just consider that this is periodic, having the time period 2 pi by omega only, the frequency decided by cosine, and this is pi by 3. This is the fundamental period pi by 3. Clear, everybody? Right. So I can say like that, right? If you have a cos omega t plus some constant k, it is periodic. I can put it like that. It is periodic with the time period 2 pi by omega, or it could be sine as well. It could be sine as well. The DC term, the k, the constant term is not going to affect this. Chalo, next question. So now that is what next question has 1 plus 2 cos pi t plus 3 sin 2 pi by 3 t plus 4 cos pi by 2 t plus pi by 4. Okay, so what is the role of this one? Just going to uplift the magnitude by 1. If the signal is periodic, if this much part is periodic, 1 plus a periodic signal will also be periodic with the period decided by this part. So you have to work on what part? You have to work on calculating the period due to these 3 parts. Okay. This is not going to affect the period. Okay. So dear, once again, what is the time period number 1? Time period number 1 is 2 pi by omega, which is equal to 2. Time period number 2 is 2 pi upon 2 pi by 3, that is going to be 3. Time period number 3 is equal to 2 pi. Also, any initial phase doesn't affect the periodicity. Already I explained you. So omega pi by 2 hai. So this is equal to 4. Either the ratio test, all of them doesn't contain pi. So ultimately T1 by T2 or T2 by T3 or T1 by T3, all will be rational numbers, right? All will be rational number. So number 1, T1 by T2, if I talk about x1 plus x2 part, okay. So what is T1 by T2? That is 2 by 3. So what is the time period for the combined x1 plus x2? That is T dash, and that should be given by 2T2. 2T2. So 2T2, 6 ho gaya. Okay. Now you will take the ratio test of T dash by the third time period left. Okay. T dash by T3. T dash 6 hai. T3 4 hai. 6 by 4. Simplified form I want. Simplified form is 3 by 2. Simplified form is 3 by 2, right? So what is the final time period? It is 2T dash or 3T3. Any cross multiplication is applicable. So what is 2T dash? That is equal to 12. That is the answer. Final time period is equal to the 12. अच्छा ऐसा भी कर सकते हो. I already told you one more method. So as none of them contains pi, all are integers. So ratio of any two you take will be, ratio of integers will be rational. So you can calculate the direct time period by taking the LCM of 2, 3, 4. LCM of 2, 3, 4 ये तो पता ही होगा ना. 3 and LCM of 3 and 4 is 12, and that is also a common multiple of 2. So LCM of 2, 3, 4 is 12. That is equal to 12. So directly, if you don't want to apply ratio test in two parts, you can directly calculate by the LCM. By the LCM, the correct answer is equal to 12. That is the correct answer. That is equal to the 12. Okay? That is equal to the 12. Moving ahead to the next. Now, this one is a homework for you. Why? Because I will be discussing it together with discrete time. There are two cases, sine of t square, right? And one more question. Because I have not started discrete time periodicity, that will be tomorrow. The rules are slightly different for discrete time. Okay, so we will consider one more case. X of n is equal to sine of n square. Sine of t square and sine of n square दोनों देखेंगे. And we will discuss both tomorrow. This is just to show you, try out for sine t square. Okay, then both I will explain you tomorrow, sine t square along with sine of n square. Okay, and there is a reason I want to explain them together. So this is the homework, and the solution of this you tried by that time, but we will discuss both the solutions tomorrow. Okay? We'll be discussing both the solutions tomorrow. Right? Chalo. Moving ahead, but before I move to the next, as you know, you will get the PDF of the session, whatever we have discussed, the theory, the conclusion, the question, the solution that I have written. The PDF will be in my Telegram group, but PDF is password protected. Okay, those who are watching the session, maybe now, maybe later, they will get the password, and the password for today's PDF will be period. Very simple, period. Period, everything in small. Period. Okay. Next question, MSQ question. Multiple select questions, so be careful. One or more options can be correct. Here. Let xt be a continuous time signal. y1t is equal to x of 2t, y2t is equal to x of t by 2. Okay. So, which is the correct statement? Choose the correct statement. If xt is periodic, y1t is periodic. If y1t is periodic, xt is periodic, etc. Now guys, x2t and xt by 2, it only represents the compression or the expansion of the signal. Now what happens if you compress or expand the signal? Is it going to affect its periodicity? Suppose I take a simple sinusoidal waveform only. Having, suppose it is sine of pi t. So sine of pi t time period कितना हो गया? 2 pi by pi. That is equal to 2 units. Okay, this is 2 units. This will be 4 units. This is going to be minus 2. This is sine pi t. If this is sine pi t, so dear, what should be? Let's say this is equal to xt. So what is going to be x2t? x2t, we all know, a greater than 2, mod a greater than 2 represents compression. So the waveform is just going to compress, but the nature remains the shape, the nature, the amplitude, everything remains to be same. Only thing is time period instead of 2 will become 1. Correct. Here the time period will become 1 eventually. The time period will also compress, right? And if you talk about the other case, that is known as the expansion. That is x of t by 2, mod a greater than 1. That is known as the case of expansion. Okay, again what will happen in the case of expansion? The time period which was 2, 2 twos are, it will go to the 4. The signal will be stretched. It will just look like expanded. Okay, it will just look like expanded. This will become 4. Okay, 2, only half cycle will come till 2. Okay, on the left side. This will become the -4. So it is extended, but there is no effect on the periodicity. There is no effect on the periodicity, right? So in general, I can tell you by this, in general, I can tell you that x of at will be periodic, right? If xt is periodic, having some period, that is t, x of at will also be periodic, but the period will change. What will be the period? It is t divided by modulus of a. First case देखिए ना, first case देखिए, a is equal to 2, so period becomes 2 by 2, that is equal to 1. Okay, second case, what is the period? 4. Why it is 4? Because it is doubled. Why it was 1? Because it was 2 by 2. Okay, so in the case of expansion, the period will increase by mod a. Okay, by divide by a only, because a is half, so t upon half will be eventually 2t, will be 2t. That is what it is. So if xt is periodic, dear, if xt is periodic, y1t will be periodic, y2t is also periodic. y1t is periodic, y2t is periodic. Now reverse पूछा है. If y1t is periodic, xt. So what is the expression for xt in terms of y1t? Dear, if y1t is x2t, so what is xt? Divide by 2 करेंगे ना? That will become y1 t by 2. Here write down t by 2, this will become xt. Okay. Similarly, fourth option, y2t is periodic. So what is the expression for xt? What is the expression for xt? So here I have to multiply 2, तो यहाँ पे भी 2 आएगा, right? So xt will be y2 of 2t, but this is again expansion case, and second one is compression. क्या बोला है? y1 periodic है, तो expansion will also be periodic. I explained you. y2 periodic है, तो its compressed form will also be periodic. That means C and D. Oh sorry, ये reverse हो गया है option. It is understood, but I think it is understood. Let me still change it. All 4 A, B, C, D are correct answers here. All the 4 A, B, C, D are correct answer here. But will the story remain same in case of discrete? Let us learn that tomorrow. Okay. One more homework यहाँ पे मैं add करता हूँ. Try similar question for discrete time. Try similar question for discrete time. Please try it out. One similar question for discrete time signal. And I will explain you tomorrow. I will explain you tomorrow. ठीक है? इसको हम देखेंगे. We will discuss that what happens in discrete time. Still all 4 options are correct, yeah, maybe there are some changes. If out of curiosity, I'm telling you, just try out, because today I haven't started discrete time, but I will help you with the complete details of the discrete time signal, but that is going to be tomorrow. Guys, one very important update for you, that yes, all those who have qualified ESE prelims, we are bringing you a comprehensive coverage for complete preparation of your mains examination, right? For your mains examination. Yes, ESE mains 2023 for all 4 branches, that is EE, ENT, civil and mechanical, right? Where you have live conventional practice classes. Okay, the evaluation by expert faculties, your complete test papers will be evaluated, comprehensive test paper will be evaluated, live doubt sessions, and this course is starting on the BYJU'S exam prep on 3rd of April. You can enroll now. You can just go to the BYJU'S exam prep app, and especially for computer science as well as electronic students, you know, NIELIT has announced huge vacancies, more than 550 vacancies for Scientist B and STA, Scientific Technical Assistant post. For that also, BYJU'S exam prep on the app, starting the course from 1st April, that is just this Saturday, which will offer you 240 plus hours of live classes, 15 plus chapter wise study notes, more than 1000 practice questions. So all these batch details, you can get it on our app. And also guys, The Sunday, as I told you in the beginning also, we are starting with the Learn with Fun to make your learning with real live the experiments, the gate concepts seen practically, understood with the experiment and understood on the board. The first video of this Learn with Fun, you will get every Sunday, but the first video, the trailer is here in front of you. We'll talk about skin effect, the important phenomena that you learn in electromagnetics. Okay, me and Ashu Jhangra sir have combinedly performed an experiment, and we'll first show you the experiment and then we will explain you the skin effect on the smart board. Alright guys, so subscribe to the channel to get all such videos, and the BYJU'S exam prep users once again have done phenomenal performance in the GATE 2023. 13 ranks under 10, single digit ranks, more than 100 ranks AIR under 100, and 62 ranks for AIR under 50, right? So that is what is the success story that continue. So guys, see you tomorrow 9 p.m. with the discrete time, periodic and aperiodic signals. The discrete time, periodic and aperiodic signals. Bye bye. Thank you. Good night. Stay safe and take care of yourself. Do solve the homeworks also.